Good morning, Van Wert. I can honestly say that I miss you all so much and I wish we were in the classroom face to face, but here goes. Remember earlier this year when we were talking about imaginary units? And I told you that we were going to deal with those later this year. Well, later this year is now. So our goal, one of our goals today, is we're going to be performing operations with the imaginary numbers. So here's what it starts out as. I squared is the same thing as -1. You just have to know that. There isn't a better explanation that I can give you for that piece of it. We all know that if you took your calculator and did the square root of -1, it would say error. So we're going to change that because we know -1 is the same thing as I squared, the square root of I squared, which will give you I. So what that looks like with different numbers is if we do the square root of -27, we're going to make that the square root of -1 times the square root of 9 times the square root of 3. We can't have the -1 under the square root, so we're going to change it to its equivalent, I squared. So now we have the square root of I squared times the square root of 9 times the square root of 3. The square root of I squared is I. The square root of 9 is 3, so you end up with an answer of 3I radical 3. Next sample, we have the square root of -18. So we're going to break that down into the square root of -1 times the square root of 9 times the square root of 2. Remember, we're always looking for perfect square factors. We could go 6 and 3, but that's going to cause us more work. We want to go with perfect square factors if we have them. -1 becomes I squared, so we have the square root of I squared times the square root of 9 times the square root of 2. The square root of I squared gives us our 3. The square root of 9 gives us, square root of I squared is I. Square root of 9 is 3. And then we have the square root of 2 because it's not a perfect square, nor does it have perfect square factors. Now, you may need to look back at your worksheets that we did when we were doing chapter 12 to work on simplifying radicals. We've done the simplifying radicals before. Okay? Next type of problem that we're going to do is called doing the product of pure numbers. Pure numbers means they're imaginary numbers. So we have -5i times +3i. So we have a negative times a positive, which we know is going to give us a negative. We have 3 times 5, which is going to give us 15. And we have I times I, which gives us I squared. So our answer right now is -15I squared. I squared we know is the same thing as -1. And when we're not working with radicals, we can change our I squared back to a -1. So now we have a -1 times a -5, which gives us +15. Okay, next time we're dealing with the square root of -6 times the square root of -15. So what we're going to do is we're going to break these into their factors, their pieces and their parts. The negative becomes -1, which is the same thing as I squared. So I skipped that step and came straight to the square root of I squared. 6 breaks down to the square root of 2 times the square root of 3. 15's factors are the square root of 3 times the square root of 5. We know that the square root of I squared is I. We know when we have the square root of 3 times the square root of 3, that is the same thing as the square root of 9, which is 3, or it's the same thing as the square root of 3 squared, which is 3. So we have our I out front, we have our 3 out front, and then we multiply what's left that didn't simplify, the square root of 2 times the square root of 5, and we multiply those back together to get the square root of 10. Okay, now I've got 2 more problems that are like the ones we just did there. If you want to look at the beginning of them and pause till you get it done and then check it, that would be great. So here's your guided practice. 3i times 4i. Okay, so the 3 times the 4 gives us the 12. I times I is I squared. We know that I squared is the same thing as -1, so we have 12 times -1, which is -12. Okay, next problem. The square root of -20 times the square root of -12. Remember, when you're factoring these numbers, there may be more than one pair of factors, but you're always looking for perfect squares. So the negative would be the square root of -1, which we're going to jump and change it right to the square root of I squared, times the square root of 4, times the square root of 5. -12, the square root of -12. The negative, we're going to jump and make it straight to I squared. 12 is the square root of 4 times the square root of 3. So at that point, we have the square root of I squared, which is I, the square root of 4, which is 2. We're going to leave the square root of 5 alone for a minute. We have the square root of I squared, which is I, the square root of 4, which is 2. So right now we have 2 times 2, which is 4, I times I, which is I squared. So right now we have I squared times 4, and then we're going to multiply the square root of 5 times the square root of 3 that we didn't do anything with, and that's going to give us the square root of 15. I squared we know is the same thing as -1. So we have -1 times 4, which is -4, times the square root of 15. Okay? Anytime, guys, when you're watching this, if you have questions or you want to Zoom about this, we can go back through any of those problems. That's the first part of what we're doing. We got 3 slides here to do today. Okay, the next one is called the square root property. We're solving again. Solving, remember, means finding your zeros, your x-intercepts, your roots. Okay, and if we took x squared plus 64 equals 0, it does not factor because of the plus sign. So if we're going to solve this, and the directions would be to solve, guess I should have written that up there. Let's put that up there so we can see it. Solve. Okay, we're solving this. It doesn't factor. So to solve this one, we're going to subtract 64 from both sides. That gives us x squared equals -64. We're going to take the square root of both sides, but we know we can't leave the negative under the square root, so that's the same thing as saying -1 times 64. -1 is the same thing as I squared, so right now we have the square root of I squared times the square root of 64. The square root of 64 is 8. The square root of I squared is I. And your answer is going to be plus or minus 8i. Now you might be wondering why it says plus or minus 8i. And if we come over here and look at this, remember, square root is saying what number times itself gives you that number. So if we do the square root of 9, we know that that's 3. If you push that into your calculator, you know that you're going to get 3 because 3 times 3 gives us 9. But wait, there's more. We could say the square root of 9 is -3 because -3 times -3 also gives us 9. So the square root of 9 is really +3 or -3. So we're going to write it as plus or minus 3. We could write it as 2 separate problems, but mathematicians are basically lazy. We want to make it shorter, so we're going to do it as one problem. So let's do another one. The square root of 36. You know if you push into your calculator, you will get 6 because 6 times 6 gives me 36. The square root of 36 is also -6 because -6 times -6 gives me 36. So the square root of 36 is plus or minus 6 because both +6 squared gets me 36 and -6 squared gets me 36. Okay, so back to the second problem over here that we're solving. 4x squared plus 100 equals 0 doesn't factor. There is a greatest common factor you could have factored out first, but if you're going to solve it by the square root property, you don't have to do that. You can. We're going to subtract 100 from both sides, gives me 4x squared equals -100. Divide both sides by 4 to get x squared equals -25. Do the square root of both sides. The square root of x squared gives me x. The square root of -25 becomes -1. -1 is the same thing as I squared. So we have the square root of I squared times the square root of 25. The square root of I squared is I. The square root of 25 is 5, and it's going to be plus or minus 5i, just like we looked at on the previous 2 examples. Okay? That's using the square root property to solve. And the last goal for the day is operations with complex numbers. When we're talking operations, we are going to be able to add them, we're going to be able to subtract them, we're going to be able to multiply them, and we're also going to be able to divide complex numbers. So your first question probably is, what's a complex number? Complex numbers. Complex number has a real part. It's going to be underlined in red here in a second, and it has an imaginary part, which is going to be underlined in black. So if I have this problem, 5 minus 7i plus quantity 2 plus 4i, the real parts are the 5 and the 2. Those are real numbers. The imaginary parts are the negative 7i and the 4i. You add your real parts together, you add your imaginary parts together. Because when you're adding or subtracting, you can only combine like terms. So 5 plus 2 gives me 7, and negative 7i plus 4i gives me negative 3i. So in this problem, you added complex numbers together. You add the real parts together, you add the imaginary parts together. We can also do the same thing with subtraction. Subtraction, we have 4 minus 8i minus 3 minus 6i. So we're going to subtract the real parts, 4 minus 3, that gets us 1. Okay, the second part, here I would probably have changed this to add op. Okay, and the opposite of 3 is a negative 3, and the opposite of subtract a 6 is to add a 6i. So our problem becomes 4 plus 8i plus negative 3 plus 6i. So we have our 4 plus our negative 3, which we already said was 1, negative 8i plus positive 6i gives me negative 2i. When you're adding and subtracting, you combine like parts. You combine the real number parts, you combine the imaginary parts. Okay, the next one we're going to go to, the next operation is multiplication. It's like FOIL. So we have 2 plus 4i times 9 minus 3i. So when I multiply 2 times 9, I'm going to get 18. Then I'm going to multiply 2 times negative 3i. 2 times negative 3i is going to give me negative 6i. I'm going to multiply 4i times 9, which is going to give me positive 36i. Last, I'm going to multiply 4i times negative 3i, and that's going to give me negative 12i squared. I squared is the same thing as negative 1, so we're taking a negative 12 times a negative 1. That's going to give me a positive 12. I combine the negative 6i and the 36i's, which gives me positive 30i. So my final answer is 18 plus 30i plus 12. Okay, you're using FOIL there. So remember, when you're doing the multiplication, remember FOIL.